Thank you. So, welcome to Wasmer Things, an upside-down guide to WebAssembly. So, I am Edoardo Vacchi. You may remember me for successful blog posts such as WebAssembly for the Java Geek. I am myself a Java geek, so when I talk to other people that do Java, they go like, WebAssembly, yeah, Python in the browser. We know that didn't really work. Well, what's to be excited about? But then we are here not just for WebAssembly in the browser, but for WebAssembly on the backend, right? And seriously now? So in this presentation, I'm going to try to give an overview of how we came to talk about WebAssembly, just giving, if you want, some other another picture from the previous talk from Taylor, and yeah, and I'm going to do that by the help of some sources, primary sources of information. Actually, I wanted to quote from this paper, Bringing the Web Up to Speed with WebAssembly, because, well, we have a bunch of people here today. They are the co-authors of this paper. And it was presented 6 years ago, right here in Barcelona. So it's really cool to be here again to talk about the future of WebAssembly. So let me just take another trip down memory lane. And a bit earlier than where we were with Taylor. I'm talking about early 2000, late 90s. These are the browsers, more or less, that we were using, including our beloved Internet Explorer 6. And all of these browsers were already capable of running JavaScript, but it wasn't really considered a proper programming language. It was more considered like a language to do button rollovers. And I mean, web browser at the time wasn't as capable as they are now. I mean, they mostly displayed text and pictures and sometimes animations. But if you wanted to do a little bit more than that, you had to resort to plugins. You had to use plugins. So the problem with plugins is that you may do basically everything, but they're native bits of code that plug into your web browser. So you could play music videos and do interactivity, proper programming, if you will. But they had a lot of downsides. They ran pretty much at the same level of privileges of your web browser. And well, you, as a developer, if you wanted to develop a plugin, you had to target all the browsers, CPUs, and operating systems that you wanted your user to support for your user. And then the other issues was that you had to keep them up to date as an end user. And you can rely on your end user to keep their systems tidy, but I'm not blaming our users. It's just putting too much burden on them. So ultimately, we decided that that was not the way to go. There could be better ways. And this guy was also the reason why we ultimately dropped plugins. Not just this guy, of course. I just mean mobile platforms that didn't support plugins at all. So, but in the meantime, we discovered that JavaScript wasn't that bad of a language. It was actually a proper language that you could use to write software. And browsers were gaining more and more capabilities. So we started to write JavaScript. But at the same time, we wanted to use code that we had already written, or we wanted to use the programming language that we liked more. So we started to treat JavaScript not just as a proper programming language, a dynamic language that just ran, but as a compilation target. And I'm just mentioning a bunch of compilers or transpilers here, just to give an overview. But there were many more, and some of them are still in use, including, as I said, I at least used to be a Java developer. And so I know GUID, but GUID is still around there in the form of Jekyll. I think we may have some talk about Jekyll too. Yeah, To the point, we were treating JavaScript as a compilation target to the point that someone called it the assembly of the web. This is Scott Hanselman's blog, which I think was the first calling it that way. So we needed and deserved a better compilation target that just minified JavaScript. So Taylor mentioned native client. So what was native client about? It was mostly a C, C++ toolchain. In the native client flavor, which was actually the first, even though it's on the right, we used a GCC toolchain, modified toolchain to generate native code that was, however, sandboxed. And we had to target all the architectures that we wanted to run on, but it was sandboxed, and we solved the deployment issue because the native payload was directly delivered to our end users like any other resource, like images and JavaScript payloads and so on and so forth. So what about portable native client? It solved another issue, the issue of portability and CPU architectures. You just target one compilation target, and then it would be recompiled on your client machine. What was the issue? Well, one of the issues is that was specific to Chrome. And yeah, so could we do better? Well, we already had JavaScript runtimes everywhere. All major browsers implemented a just-in-time compiler for JavaScript. These are pictures from the comic that presented for the first time Chrome with V8. But pretty much every other major browser brought JavaScript just-in-time compilation to the mainstream. So we had already a platform. Could we target it in a better way instead of just generating some JavaScript? And that's where ASM.js was released. It was a proper compilation target, but defined as a subset of JavaScript that browsers that were aware of that target could actually use to generate ahead-of-time native code that was performant. And the Unreal demo demonstrated really that was feasible and was actually pretty impressive for the time. So, OK, let's go back to the present, or actually to 2015. It was in October, but that was the date, that was the year where WebAssembly was first announced. And so back to the actual present. People that have been using Java and other platforms such as CLR are still thinking, is history repeating? Are we doing over and over again the same things, the same mistake? We all know probably here that that is not the case, but I wanted to give you a comparison to better understand why people are asking themselves these questions, and actually to prove a point, to really show that there is a reason why they are doing that. So the JVM, on the surface, really looks like WebAssembly runtimes. So there's a bytecode representation. You compile your source code into bytecode. There's a stack-based VM. It can run on the client and the server. And the bytecode could be interpreted, or could be just-in-time compiled, or even compiled ahead of time. CLR, pretty much the same thing. All right, so yeah, case closed. We're just reinventing the wheel. We should have just gone with a JVM. Write once, run anywhere, debug everywhere. Am I right? The thing is, JVM, the Java bytecode was never really meant to be a general-purpose compilation target. This is not just a wild claim that I'm doing just to justify the WebAssembly is better. There are actually papers. This one I wanted to mention because Taylor mentioned JRuby. And this was the first paper where I would say it was acknowledged that the JVM was being targeted by other languages, in particular dynamic languages. And we're going to see a talk about dynamic languages on Friday on WebAssembly. I don't know if there are others. Definitely there's one on Friday. So bytecodes meet combinators invoke dynamic on the JVM. It was the first time we were acknowledging that dynamic languages wanted to run on the JVM. A new instruction was being introduced to the JVM to better support these languages. And I'm quoting from the abstract. The JVM was designed for just one language, Java. And so when it is used to express programs in other source languages, there are often pain points, which makes it harder, right? So besides, now I'm quoting from the PLDI 17 paper. PLDI is a premier venue for programming language research. It was presented in Barcelona. Bringing the web up to speed with WebAssembly. So JVM bytecode verification takes 150 pages to describe, while WebAssembly takes 1 page. It took a decade to get it right. Definitely we don't want that for something that runs in a browser, or for that matter, anywhere. And JVM, CIL, and Android Dalvik allow bytecode to create control flow structure that can get the just-in-time compiler confused. So again, that's probably something we don't want. So let's say bye to old Duke. That's not what we want. What about LLVM? It's a VM, right? It's a collection of modular and reusable compiler and toolchain technologies. This is the web page, the home page for LLVM. They actually say on the home page, despite its name, LLVM, it is not really a virtual machine. The name LLVM itself is not an acronym. It is the full name of the project. That is actually not true, at least not in a historical sense. It used to mean low-level virtual machine, but it is true now that it was confusing because people, when they heard virtual machine, they thought, oh, I can run this code. You really cannot. I mean, LLVM was shipping an interpreter in the very first versions. I mean, there are experiments to actually do it. There's WebVM on the JVM that does it. But if you take a close look, it has a bunch of issues. Again, quoting from that paper, we investigated, and we here is the portable native client developers. Portable native client was portable because they were using LLVM bitcode. Now, it is a bytecode representation. What's wrong with it? Can't we use it? Well, not really. It is not entirely stable. It changes across major versions. So again, the browsers, we don't want to break the web, so that's an issue. But even if that wasn't an issue, it has undefined behavior. Do you want that on a portable runtime? It was found to be less compact than a stack machine. It essentially required everyone to either ship LLVM or re-implement a part of it. Of course. And of course, LLVM is known to be slow. So again, not great. So what about other compiler IRs? So the main issue with compiler IRs, and that's why the VM in LLVM can be confusing, is that the IRs are meant for doing further transformations, not really for immediate execution. So they're not necessarily compact and not necessarily easy to verify. So again, goodbye to the wyvern. So that's how pretty much we got to WebAssembly. WebAssembly offers compact representation, efficient validation and compilation, and safe low to no overhead execution. As compared to, say, the JVM, it's an abstraction over modern hardware. Why, for instance, the JVM bytecode is really lower level representation of the Java language. I'm going to show you a few examples of that in a little bit. And this makes it a portable platform for language hardware platform independent, and it can be used outside the web, and that's why also we're here. There are many supported languages. This was from one of the excellent Fermi's blog posts. Doesn't mean to be complete, this list, because it's just growing every day. Now I want to give you an overview of the architecture. So I mentioned already that the JVM is a stack machine, and we know that WebAssembly is a stack machine, so they're the same. Right now, they are not really the same. One of the examples in which they differ is that they are yes, they do computation on a stack of values, but they use structured constructs for control flow. And let's see. So there aren't jumps. there are blocks, ifs, and loops. And we're going to see an example of that. But first, on the surface, they really look alike. So let's see an example. There's the x variable, and then I sum that to 2, and then the result I'm going to do times 3. So on the left, you see JVM bytecode. On the right, you see WebAssembly in the WAT format, WebAssembly text format. If you look at them, first you load the variable x, and then push that on the stack. Then you get the constant 2, push that on the stack, pop 2 values because you're doing an add, and then push the result in the stack. Then you push the value for constant 3, and then you pop them both because you're doing a multiplication, and then you push the result. They're pretty much the same. You can just jump with your eyes left and right, and it will be exactly the same sequence of instructions. One of the differences with the Wasm text format is that you can also write it in a nested representation, which is reminiscent of scheme, which is obviously sort of an inside joke about the origins, really early origins of JavaScript. And the thing is, this representations really is just mostly cosmetic, because if you follow the order of well-parenthesized expressions, it just linearizes to the one on the left, which is nice because it's more readable, but it's pretty much the same. So we were saying that the issue with JVM, CIL, and Android Dalvik bytecode is that you are able to create pathological pieces of code that can get the just-in-time compiler completely confused. And in contrast, WebAssembly has this structured control flow, which makes validation and compilation faster, simpler, and of course can be extended for further types of control flow and even lock-in structures. So let's see an example again for Java bytecode, and that's because, as I've told you, I'm more familiar with it, but that's the same for other bytecode representations. So we have a very stupid if, then else. If x is true, then I'm going to print 1. If else is false, going to print 0. Sequence of instructions is not really important. What I want you to see is that we have this jump here, jumps at instruction 14, and then we have a go-to here that jumps at 21. And there's no restriction on the point where you can jump in the bytecode. So that's why you can really mess things up here. As opposed to WebAssembly, that really has structure, it actually kind of reads like a normal programming language. You have an if, you have a then, you have an else branch. And this is the structured, the nested representation, but even the linearized version still maintains the structure. And this is one of the reasons why it's safer and gives you more guarantees. So that was just one example of how they differ. Now, I want to give you an overview of the landscape also. It is not meant to be complete. We have 2 days to make it more complete. I'm just going to name drop a few relevant runtimes, but of course, we're going to get a better picture in the next hours and days. So, well, of course, I want to mention Docker. As you know, they have just released their Wasm support, and yesterday, I think, they just announced an extension to it. The first runtime they were supporting was Wasm Edge, but now they support many more, including Fermi and Spin, and Wasm Time, and a slide from Days Labs. So Wasm Time, I guess everybody here knows it. It's the most widely known runtime. And a lot of other projects are based on it. I wanted to mention Docker also because we hear a lot that Wasm is an alternative to containers, and I wanted to explain maybe why we say that. So what are Linux containers? Linux containers are a technology that puts together sandboxing, packaging, and distribution. So sandboxing is through a bunch of syscall that are in the Linux kernel that allows you to expose only a part of your environment to the running executable. And this is basically delivered through WASI because it's a capabilities-based set of syscalls that provide you with that kind of safety. As for packaging and distribution, Docker is providing that through their registry infrastructure. But there are also ecosystems that are trying to spin off their own kind of thing, such as Wasm. WAP is part of the Wasmer umbrella, which I wanted to mention because, of course, the title of the talk is also inspired by that. But also, so this is for running outside the browser and kind of standalone applications, container-like. I wanted to mention the other great use case for WebAssembly, which is extensibility of other applications. So Envoy proxy is supporting WebAssembly for doing filters and transformations. Similarly to Red Panda, which is an alternative Kafka implementation that allows you to write filters and transformations and run close to the core, close to your data, using WebAssembly. So allowing you to write using any language that is able to support it. So pretty cool. We're going to have a talk about Lunatic, and I think it's Lunatic plus Grain, pretty cool, on Friday. I think this is not often talked about. It's a runtime that's based on Wasm time, but provides capabilities for you to run applications in an Erlang-like fashion. So instead of writing processes, actors, only in languages that are able to run on the Beam VM, that is Erlang, maybe Elixir, and a bunch of others, you can write them using any language that is capable of targeting WebAssembly. So that's pretty cool. And of course, Crustlet is probably the first project that promoted running WebAssembly payloads on Kubernetes. But also, I wanted to mention crun because it's another project that allows you to run WebAssembly on a cluster. Sandboxed on Linux and in general also on a cluster. We're going to have a workshop, I think, tomorrow about OCI and WebAssembly from Tony. I wanted to mention a weird use case because I'm that kind of guy. I like compilers and weird stuff done with compilers. So Zig programming language, lesser-known programming language, but pretty cool. They used WebAssembly to bootstrap their programming language, their implementation. Usually, one of the ways you can bootstrap your implementation is by writing an interpreter for a subset of the language. And they just said, why should I do another interpreter when I can just use WebAssembly as a target and then bootstrap that way? Pretty interesting, pretty cool. And then, of course, let me spend a couple of words about WaZero, because that's the project I'm working on, Tetrate. It's the one, I would say, or at least one of the runtimes that run on Go without CGO. So you can run any WebAssembly runtime and link it against the Go runtime, provided that you use CGO. So if there are Go developers in the room, I know there are some, they will be familiar with CGO, but for the people that are not familiar with it, basically, it's a flavor of the Go language, if you will, in runtime that has some constraint. And you give up a lot if you're using CGO. So you're able to link against native libraries, but you give up some of the benefits that you have by choosing Go in the first place. So there are a bunch of cool use cases for WaZero and Go that I wanted to show you. And one of the things, since CGO has this kind of friction with the runtime, is using WebAssembly as an extension language through WaZero for doing foreign function interfaces. And this blog post was very funny. Customization of Go programs was about using a Rust library inside your Go program for doing some stuff. So that's interesting. Dynamic linking. So one of the selling points of Go is creating a static binary that you can deploy anywhere. But what about dynamic linking? Where that's something that basically you give up unless you use CGO. So by using WebAssembly, you don't need to give that up, because you can use WebAssembly as a form of dynamic linking, basically. So language extension, program extension. Wanted to mention Dapper because they're using WaZero to deliver HTTP, to let the user develop HTTP middleware. And there are others. So in fact, you are cordially invited to the 1.0 launch party happening on March 24th, so Friday at 7 p.m. It's a 10-minute walk from here. This is the official graphics. I think my graphics was much better, but whatever. I'm not taking it personally. So if you want to get there, there's an RSVP on the app for the conference, but this is also the Eventbrite link. You can register there. We're going to have some food, some drinks, and a bunch of awesome lighting talks from our community. Some of the folks are, of course, at the conference giving talks. I couldn't list all of them here, but yeah, we're going to also have an introduction from Takeshi, who's the founder of the project. So it's going to be awesome. Hope I'll see you there. Thanks you for staying with me, and hope you'll enjoy the rest of the conference. Are there any questions? Good. Everything was crystal clear. I mean, preaching to the core here. So I'm happy to talk to you. Oh, there is a question? Oh, there is one.
So basically, as WebAssembly matures, do you think that there will be even more and more specialized runtimes, especially given how simpler WebAssembly is compared to say some other specifications, or do you think like naturally it will get more consolidated? Or what's your take on?
Yeah, that's an interesting question. Probably we can't really tell right now. Maybe we're here also to discuss this in a way. I think that specialized runtime are actually an exciting part of the WebAssembly ecosystem because it's not just one size fits all. There are multiple use cases. I think the next talk will be about edge. So there are talks about embedded runtimes. So I don't know if we will converge on one runtime. Actually, I would hope that we're not converging over one runtime because, I mean, platforms like Java and .NET kind of suffer for having not that much diversity. It's not like there is only one implementation. There are a few, but at the end of the day, there are not many. So I think it's cool that we have that diversity because the specification is sufficiently small that we can have more flavors and specialized runtime. So probably, I hope not. Hope we'll keep those. There's a question there.
First of all, great talk, and congratulations on the WAS0 release.
Yes, thank you.
So my question is, do you think there's any parallels that can be drawn between the openness of platform, operating system, low-level software architectures, and the same thing that's happening in hardware with new processors like RISC-V?
Huh. That's an interesting question. I don't know if I can answer that. I mean, yeah, we're seeing an interesting, it's an interesting time, honestly. We are seeing that there is movement, and it is really interesting that RISC-V is being developed as an open platform. And it is interesting that WebAssembly itself has been realized and defined as an ISA. So the thing is, there could be some sort of interaction between these two words. I don't know how, but we're living interesting time. I don't have a clear answer to your question. It was kind of open-ended. But yeah, I hope we will see more openness even in the hardware sector as well. Yeah. There's another question here. I hope I can answer this one. Thank you for the question, by the way.
Yeah, I guess it's an easy question. Thank you first for the talk. It was a very interesting one. Coming from the adoption perspective, what do you think are the yet to be delivered things that we need for a bigger adoption of WebAssembly and WebAssembly technology?
That's a very good question. So what do we still need? So a friend of mine was skeptical about WebAssembly, and he bluntly asked, "Yeah, what can I do which is not a calculator with this?" So WASI and in general host function and specialized runtime are an answer to that. We definitely need a set of syscalls, APIs, libraries, don't know what you want to call them, but a set of shared platform that is not just the core runtime that we can use and to do proper actual work. So WASI goes in that direction, and we're going to need probably an ecosystem of libraries. Like, I don't know, I'm just thinking from the top of my mind, things for doing numerical analysis, for instance, things that people need. And then probably the adoption will come with itself because of the benefits of running everywhere are there. I mean, they're just, I don't think that's debatable.
Thank you.
Oh, another question.
Hi, thanks for the talk. Also a bit a general question. Aren't we all a bit worried about the speed that things are shaping? Specifically, I'm talking about specification for interfaces, which became modules, which became components. And yeah, we've lived through pandemics, obviously. 2 years wasted, I guess. But aren't we all a bit worried that things aren't developing fast enough? Not in general sense, but some people have compared the interfaces with core by IDLs and COM IDLs and stuff like that.
Right.
And these things went nowhere. I mean, de facto nowhere. Yet they were aiming at the same thing. Like, let's mix languages. Let's develop components in different languages. Is there any hope that these? We've seen the slide from the previous talk about how these things may look like, and they look very complex, and that's normal. I mean, we've seen this before. Us who have lived through COM and Corba and all that, we've seen that this is a hard problem. Are we sure in a way that it's going to be solved? I mean, what's your take on it? Thanks.
Okay. So actually, at the beginning, I thought the question was, isn't this moving too fast? And then because, you know, in a way, kind of feels that way. But on the other hand, you're right. I mean, there have been a lot of evolutions that went extremely fast in a way. But then to solve proper problems, maybe we're not moving fast enough. I don't know. I mean, it is a complex issue. I mean, you have to move an entire community and get consensus. And if you want to do that properly, you want to do it in a way that you actually get consensus. And that's a major issue. I mean, we cannot just be driven by one specific interest so that we can deliver faster. And unfortunately, one of the pain points of moving as a community is that things will move slower. And so I guess the point I'm trying to make is that there are proven technologies that you can embrace today for doing anything. And WebAssembly maybe is not ready for everything right now, but for some use cases is a promising technology that you can already adopt. And I think it is worth investing in it anyway. There's another question. I don't know if there's enough time, though. OK.
As a fellow old Java person, do you have any opinions on kind of Graal and some of the newer work coming out of the JVM? Because, you know, historically, technologies always copy ideas from each other and get inspired. And, you know, as Graal advances, is that going to potentially negate folks moving to something like a WebAssembly type setup, since Graal could handle some of those needs for those type of languages. So I'm just curious of your
Yeah,
your
so
thoughts here.
there's a flavor, if you will, of this talk that is more oriented towards Java developers, and I cut some of the slides because I didn't want to bore the rest of the audience, and thanks for the question. So the reason runtime that I haven't mentioned for Java, which is called GraalVM, which I've mentioned, it was born as an experiment or runtime like 10 years ago, or maybe more than that now. Yeah, about 10 years ago. And now called Java Ecosystem by Storm with their native compilation capabilities, but it's a polyglot runtime that is able to run a number of different languages, dynamic languages, as well the LLVM bitcode, which I previously said couldn't be run. It can be run. They also provide a WebAssembly runtime, and I hear they're considering using LLVM to generate code, which will make it possible also to target. They're already targeting RISC-V through that, and it probably makes it possible to target WebAssembly as well. I don't know the status of that, except for mention in a blog post on Medium. So I think they're thinking about it because there's a lot of buzz about WebAssembly, so probably they're considering it. I'm excited to see what will come out of that. I know there are also other efforts to compile Java to WebAssembly or to run WebAssembly on top of Java. I didn't have enough time to talk about that, but I have a few slides if you'd like. All right, thanks again, and see you around.